Welcome to today's discussion. Today we are going to talk about container orchestration using Docker Swarm. Yeah. My name is Amit. So let me just write it down here as well. My name is Amit. I'm based out of Bangalore, which is in India. If you are not familiar with the city, and I have around 18 years of experience in total IT technology. I have worked most of those 18 years on DevOps related technologies. So version control systems, CI/CD, cloud, container environments, monitoring, everything around that. Yeah, including automation. So I'll be your discussion partner today. Today we are going to talk about an exciting topic, which is container orchestration using Docker Swarm. We have already covered in some of our previous webinar a little bit about Docker Swarm. Yeah. So what is Docker Swarm? What are containers? How does not Docker Swarm, but Docker. So we have already covered what is Docker, what is container, what is an image, how do we execute a container, how do we deploy our applications in containers and things like that. So this is in continuation of that discussion. If you are not sure about what is Docker, then I recommend please brush up on Docker first. In this session, we are not going to talk about Docker or the basics of containers like images and containers and things like that. We are specifically going to discuss about container orchestration using Docker Swarm. So today we are going to talk about what is container orchestration, how does it work, and why it is required. And then we are going to have a small demonstration explaining the technical implementation of that. So technical demo. And we'll have some time for Q&A. And then we are going to wrap up the session. Okay. So let's not wait anymore and let's quickly get into the topic. So we all know what are containers, right? So containers are small, I would say, small processes, right? Containers are small processes which kind of simulate virtual machines, but very tiny virtual machine. So I would just maybe create a different diagram here. Yeah. So a container contains your base OS libraries, right? And any dependencies to run your application, right? So if you want to, let's say, deploy an HTML based application, so you have your application code, maybe as an example, let's say if you have an HTML based application, so you have your HTML app here, right? So your HTML files, then a dependency is you need to have an HTML server, like maybe Apache or Nginx or any other server. And then you need basic operating system libraries. So maybe you want to base this entire system on CentOS or Ubuntu or Alpine or whatever, right? So all this, the complete application along with the environments is known as containers, right? So if you are a vendor of a web application, you can put everything together in a Docker container and share it with your customers, your partners, and they can execute this application in any environment, right? Now, let's say there are your customers who are running this application. So this is a containerized application. And let's say there is a customer who has a server. They have a server and they have Docker installed on it, right? And they run this application. So their application is running, which is nothing but this container. Okay. So a containerized app is executing. Now you can expose this application on a port, right? Let's say, for example, you expose this application on port 80. Any user can access this application, right? So if they go to the IP address or the host name of this server, they can access this application, right? Via their browser, right? So they can request here and they will get a response back. on this port 80. Now, running containerized applications is fine, but there are some problems with it. For example, how do you ensure the availability, right? How do you ensure let's take a different color. How do you ensure the availability of this application? For example, what if this container crashes? If this container crashes, although this port is available for the users, but there will not be any process to respond to requests. Yeah, so application availability is gone. What if this application is available, the container was running successfully, but this entire host went down? Right? In that case, nothing is available for the customers. Right? So availability has to be guaranteed, especially if it's a customer-facing application. It has to guarantee certain level of availability. But with this setup, it's not possible. Another thing is scalability. So let's say there are millions of users accessing your application. Yeah, let's say there are 20 million users accessing your application. Would this one server be sufficient to handle such kind of load? Right? No. Single container on a single machine will definitely be bogged down with so many requests, and it will result in unsatisfied customers with a lot of timeouts, incorrect responses, half responses, old responses, not refreshed responses, and things like that. So scalability is required. You need to scale up or scale out your infrastructure to be able to accommodate increasing or decreasing number of users, right? So this is also not guaranteed here with this setup. Then comes management of the containerized application. If somebody wants to upgrade the application or migrate the application or restart the application, you guys need to have proper authorization, and then you need proper permissions on the systems. Somebody has to log into the system and manage it, right? So that is also one of a challenge here. So how do we mitigate these challenges? We mitigate these challenges by not running the container on a single machine, but providing a cluster of machines on which our application can run. So instead of running this containerized application like this, here as a one container on this one machine, what we are going to do is we are going to create a cluster of machines. So instead of running on one machine, we will get maybe 3, maybe 4, maybe 10, maybe 100 machines. Let's say we get 3 machines. Okay, so system 1, or not machine, but let's say server. Server 1, server 2, server 3. Now, when any developer wants to deploy their application, they can just deploy it on the cluster, and the cluster will decide if it's going to run on this machine or this machine or this machine. Okay. Now, how do we do that? That's the point of today's session. How do we set up this cluster? How do we get the applications deployed or running on our Docker Swarm cluster? Okay, so before getting into the architecture and how does it work, let's see an example. So now we have 3 servers here. I have already got 3 servers, 3 brand new servers, which I just spin up on AWS. So this is server 1, this is server 2, this is server 3. And let's say, let's call it as the leader. One. Okay. Let's say these are 3 machines, right? Similar setup. One of the machine is going to act as a leader or a manager, right? And that is the machine which will be responsible to manage this entire cluster. You need to identify beforehand which machine needs to be the leader or the manager. Although you can change it later, but at first you have to identify one leader. Let's say this machine is the leader. We identify this as a leader, this machine. So what we are going to do is we have to first install Docker on all these systems so that they can run containers and run Docker Swarm. So we need to install Docker on all these systems so that they are capable of creating a cluster. So I'm going to install Docker on all of them. It's pretty straightforward. Just like this. And here as well. Done. Docker is installed on all my machines. If I go to the first machine, which I identified as leader, if I just run the command Docker, I should get some output. Yeah, this is enough for me. Okay, so Docker is installed. Now I want to create a cluster. I identified this machine as my leader, so I will initialize a cluster here. Okay, so I'm going to say, just give me a second. Right, so I'm just going to run the command Docker swarm init. So Docker subcommand swarm, then init. This is a command which is going to initialize the cluster. So it's going to mark this machine as a leader and start a cluster. Okay, press enter. Very quickly, you will see an output, swarm initialized. Current node is now a manager. Okay, so this is a manager or a leader. If you want to add more workers to this swarm, run the following command. So if a machine is leader, this machine is going to be responsible to manage this entire cluster. Now, what do we mean by manage? We will see later. But the other machines which are not leader are called workers. Right? So worker 2, worker 1. Now here, this machine is initialized as a leader and swarm is running here only on one machine. We need to connect more worker nodes to this leader. Okay, now let's connect them. So here we have, when we did Docker swarm init, we got an output to add worker nodes to this swarm, run the following command. So this command should be run on all the worker nodes that I want to connect to this swarm. So I'm going to copy it and then run this command here. And it says this node joined a swarm as a worker. And on this machine as well, this node joined the swarm as a worker. So now our cluster is up, as simple as that. If I say Docker node ls, so Docker lists all the nodes. So any machine that is connected to the cluster is called a node because it is part of a cluster now. Okay, Docker node ls. And what do you see here? Let me maximize this. We see here that there are 3 nodes available. Right? This is the node ID. So each node gets a randomly generated ID. Here is the host name of the node. So you can see 249 here, which is this one. And you can see the status, manager status, and this machine is the leader. Okay, other machines don't have any manager status, so that means they are all workers. All the machines are ready and active. That means they are ready, connected to the cluster, and you can deploy containers or applications to them. All the machines are running 20.10.25 version of Docker. Okay, So our cluster is up. We have a leader, a worker 1, and a worker 2. Right? Now, let's deploy a container on them. Right? So if you remember, when we want to run a container, on the machine where we want to run the container, we will run the command docker run and the image name. Right? Something like this. But in cluster, how do we deploy application? Now, the benefit of using cluster is if on the leader, I tell that, hey, deploy this container. So run a container. If that is my intention, I tell this intention to the leader that, hey, leader, I want to run this application, which is based on this Docker image and this port and all these things. The leader is going to identify that among this cluster, which is a node which should be able to run the container. So as a user, I am not going to identify a system or a server or a node and run the container there. I'm going to let leader decide where to run the container. I don't care about it. Right? So what I'm going to do is I'm going to give this command docker service. Okay, service is the command which allows you to deploy an application. So docker service create, and I'll give it a name called my SVC, so my service, and it is based on, let's say, HTTPD. Docker service create. This is the name of the service that I want to give, and this is the image name from which I want to create a service or an application. Press enter, and you get some output. Output is done. And now, if I list my services, so Docker service ls, you will see that a service is created. This is the unique ID of the service, which it automatically generated. This is the name. This is the mode of the service, which I will talk about later. And this is the replicas. Again, I'm going to talk about it later, but this is based on this image. Okay. So a service is running like this, but where are the containers? So if I say Docker service PS, remember Docker PS command, which lists all the running containers. Now it's going to list down the containers belonging to this service. Docker service PS, and I'll give the service name, my SVC. And now you will see this is the container running. And this is the container. The name of the container is my service.1. This is the image. This is the node on which it is running. So it looks like this is this node itself. The desired state is running and the current state is also running. Right? So you are running a container. Okay. And now, see, you just started a service. You didn't define where the container should run. The leader automatically defined where it should run, which is, in this case, it identified this. Let's create another service. So I'm going to say Docker service create my service 2. And this time, let's say I want to create it based on Nginx image. Press enter. It's going to create another service. Done. If I say Docker service ls, you will see two services now, my service and my service 2. And if I say Docker service PS, and if I say my service 2, for Docker service PS, you will see that Docker service, my service 2 also has a container running, but this container is running on node 188, which seems to be this one. Right? So this is how your services are running, or this is how your applications are deployed on a cluster. But what's the benefit? All right, I started a service, the container is running, it is running on a random node. What's the benefit? Now let's come back to the problems that we saw with the standalone server and running containers on that. Availability, right? Availability. Let's see if the availability is proper. Now, I know that there is a container running on this machine. If I say Docker container ls, there is this container running on machine as part of Swarm, right? You can see that this container has this ID. It is based on Nginx image, and the name is myservice2.1, something like that. Let's delete this container. On the leader, if I say Docker service PS myservice2, if I list the containers of this service, I see this one output. Right now, there is one container running. Let me be sneaky and just delete this container. Docker rm-f, and I'll just delete this container. Container is deleted. Now, if I say Docker service, list down the containers, what do you see? The cluster immediately identified that the container has died, which was started previously. It has died. So desired state is shut down and it is failed. So what did it do? It immediately started a new container, which is a replacement container. This is a replacement container. And it is now running on node 127, which seems to be this node. So immediately, if a container dies, the cluster is going to identify that there is a problem. There was an application supposed to be running in a container. It is not running. So let me start a new one. Okay. Scalability at the container level is guaranteed. Sorry, not scalability, availability. And the same happens if a node dies. If I abruptly power off this node, then Swarm is able to identify that, hey, there is supposed to be a container running, but looks like we are not able to reach the node. So we have to do something. We have to start a replacement container, and that will be done. Make sense? Is it making sense? I'm going to take questions later. So if you are typing your questions here, I will have to request typing them again later when I open the floor for Q&A. Right now, I'm not doing Q&A. All right. I'm glad that it makes sense for you. So this is how you deploy your application. Okay. Now let's come back to the second problem, which is scalability. What if there are many people who want to access this application? Right now, we are running one container. Can we scale it up? So first is, yes, we can first of all add as many nodes as we want on a cluster. I think the limit is you can add 5,000 nodes, but I have rarely seen a cluster with 5,000 nodes. And it's very difficult to maintain. So you can add many nodes. What about the containers? So you can also scale up or scale down your containers. Yeah. For example, let's say Docker service ls. And you see here, the service, my service, is running with one replica. That means it is running one container. If you want, you can say Docker service scale. And you can say my service equal to 3. Change the scale of my service to 3. Right now, it is running at scale of 1. Set the scale to 3. and done. If I now say Docker service PS my SVC, you see the containers are running, and it has started running these containers on various different nodes. I can set the scale to 10. Now 7 more will be started. If I say Docker service PS, you will see now 10 containers are running. So you can scale your application as and when required. Right now, these containers are being spread across only these 3 nodes. But if you have 10 nodes or 20 nodes, then your application will scale across nodes. You can reduce the scale also. You can say the scale to be, let's say, 2. And now you see only 2 containers running on these nodes. Right? This is how you solve your scalability issue. You can also scale automatically based on resource utilization. If you see that the containers are utilizing 70% of the node resources, then all right, time to create a new container on a different node. So all that is possible. And once you are done with the service, you can replace the service as well or delete the service as well. You can say Docker service RM my SVC. And done. Now all the containers are gone. The entire service is gone. Okay. Now, if a service is running, how do a person access it? Let's say I am running an HTTPD or Nginx-based application. How do I access it? Yeah. Let's solve that problem as well. So let's say Docker service create, and this time I'm going to say web app and HTTPD. Right? Create a service called web app based on image HTTPD. This time I'm also going to mention something like this: mode global and, or let's say 8080. I'm going to explain what is happening. Press enter. So I run a service now, but I did a couple of new things, which I'm going to talk about later. Yeah. But if you see here, if I say Docker service PS MySpace or web app, there are many services running here, right? 3 services. Let me find out the private IP of these, and then let's access those. So with this option, I mentioned that expose the port 80 of the containers which are running. So there's an application called HTTPD running on each container. So in the container, there is an application running on port 80. Make it available on port 8000 of my servers, on my nodes. So if I go to the IP address of the node and access this port, I should be able to access the application. So let me find the private IP address. And let's open a browser here as well. So this is a private IP address. And if I say 8000, sorry, I need to get public IP address. Yeah, not private. All right. And it says it works. Right. I'm not sure why this form is being published in the chat. Please do not. I'm not sure who is publishing this? I don't know. Okay. Unless it is official from organizer or someone. Okay. So this is your web application. You can just access from anywhere, right? This is how you can access. You can publish your application like this. Now, there is also something called as mode global, which I used. What does that mean? So when you create a service, just like that, so the services are actually, there are some modes in which a service is created. By default, the mode is replicated, right? Replicated means if you create a service which will result in a container, let's say you run a service which said run one container. So it will run a container and that container may run anywhere on the cluster. Let's say the service results in a container running here, which is fine. You can manually scale up or scale down that service as well. So you can say scale set to 3 and then new containers start running here and then here. You can say scale set to 2 and then only 2 containers are running. So you can manually manage the scale of an replicated service. By default, the services that are created are replicated service. But sometimes you may want to say that create a service where each node, if there are 20 nodes or if there are 3 nodes, each node contains one container each of that application, right? Doesn't matter how many nodes are there, each node gets one container. That mode is called global. That means you want to run your service on the entire cluster on all the nodes. That is called a global mode. Okay. In a global service, you cannot define the scale. The scale is equal to number of active nodes. Right? So that is why when we created the global service like this, the global service, it created 3 containers for me. It did not create one container. It created 3 containers for me. Right? We can see here. And one on each node. I cannot manage the scale of this service. Right? If I say Docker service scale and web app equal to 5, I will get an error. Scale can only be used with replicated or replicated job mode, not with a global mode service. Okay, this is called a replicated service. So this is how you can create services and deploy services like that. Once your services are done, you can simply get rid of them by doing a Docker service RM, let's say web app, and removed. Right? So with this, I'm going to conclude my technical explanation. Let's spend around 10-15 minutes on Q&A, and then we wrap up the session as well. So if you have any questions, please jump to the Q&A section and ask me the question. There is a question, can we get recordings of the Docker session? I think that is already answered. It is done. There is a question called Docker Swarm versus Kubernetes. So Docker Swarm is a container orchestration solution, and Kubernetes is also a container orchestration solution. Docker Swarm is by Docker, Kubernetes is by, it was invented by Google, but then it is owned by Cloud Native Compute Foundation now. So the owners are different. Docker Swarm is not industry standard. Kubernetes is industry standard, but still many organizations use Docker Swarm because of ease of availability and uh, they get it free with their Docker licenses, so they don't have to worry about anything else. So yeah, the basic architecture is same, but then how Docker Swarm works is different than how Kubernetes works. The components are different, how they handle the scaling and all is different. Okay, so this is also done. Question, Docker create service, name, mode. Okay, so this is an example of a global service. Could you please help me how you create 3 nodes in this line? So it is automatically creating 3 nodes because there are three. So it is automatically creating 3 containers because there are 3 nodes in my cluster. So with a global service, the number of containers is equal to number of nodes. From which repo, okay, next question. From which repo the manager fetches the images? So manager is using nothing but Docker. So Docker pulls from Docker Hub. You can specify different registry, but by default it is Docker Hub in case of Docker. What does -p 8081:8080 means? So this is covered in Docker session. The -p, this one means that this port on the server, this port of the server, if any request comes to this port of the server, is going to redirect to this port of this container, whatever are going to be started as part of this service. So if anybody tries to access this port, the response will be given from the container of this service and this port. Okay. What options do we have for auto scaling of containers and nodes in Swarm? So Docker Swarm has its own auto scaling solutions. Let's go to, yeah. So Docker Swarms does not have a built-in solution. Yeah, that is one of the limitations. But you can, either install plugins to bring up auto scaling, or you can write your own automation using monitoring tools and things like that. Okay. How are networks handled in the cluster between nodes? The network between nodes is overlay network. So if you just go to your cluster and say Docker network ls, you will see that an overlay network is created, which is called a swarm, right? And this network allows communication among all the 3 machines. Because my saving things going, you create 10 instances and scale down with 2 instances. I don't understand this question. So how, why? Because my saving things going. Can you please rephrase your question? And I'm not looking at the chat window. Please ask me on the Q&A window, please. Can we run application container on leader node and is it recommended? You should not run on leader. It is not recommended because it can hamper with the performance of the cluster. But by default, the leader runs the containers, but you can disable it using various solutions. Difference between cluster and node. A cluster is a collection of nodes. So 3 nodes make 1 cluster. Okay. Can you force a container to be installed, initiated on a specific node? Yes, you can. If you are running a service, you can define in the configuration on which node it should run. Although it is against the principle of orchestration and distributed execution, but yeah, that is possible. Docker Swarm and Kubernetes has any means of interoperability? Unfortunately, no interoperability possible with them. What is a service in Docker? How it differs from a container? I just explained this in detail. Is scale up and scale down happening automatically using schedule script? You can write a schedule script. Docker does not provide any native support for auto scaling, but you can use external solutions. What if the leader machine shuts down? Okay, good question. What if this leader machine shuts down or it's lost? What happens to the cluster? So if you have only one leader and it shuts down, then you almost lose everything on your cluster. That is why you can have more than one leaders. In a cluster, you can have more than one leaders. And if one of the leader goes down, the other leader assumes the responsibility of leader. Okay. Difference between storage and storage domain. So storage domain allows you to mount different storage solutions. That's the only difference. Storage is the actual storage. A storage domain is the different capabilities of Docker. Difference between Docker Kubernetes, I think I answered this. Can we run ls node command from any or only from leader? You can run management commands only from leader, like listing down nodes, listing down services, listing down containers can only be done from the leader node. Just give me 1 second, guys. Somebody's at the door. All right. So I'm going to be taking 3 or 4 more questions, then we'll wrap it up. What if manager node goes down? This I already answered. What exactly the difference between service and a container? I think I answered. Service is something which manages the containers, right? So it's a uh, abstraction on top of containers. Docker Compose can be used with form. Yes, you can use it using Docker Stack. Okay, you can read more about it. Auto scaling. So how to implement conditions where based on the load you want to kick off more containers. That's auto scaling. And you can use external solutions to auto scale. But then if you're using Kubernetes, you can auto scale automatically. All right. I won't be able to answer more questions. Yeah. I think most of the questions are already answered. Now we can have follow-up sessions. For example, if you really want to know how we can, um, you know, deploy using Docker Compose on a Swarm cluster, we can do that definitely. We can also deploy various subset of applications. Yeah, so we can do that. We also, I think, did some sessions on Kubernetes, but I can do some dedicated focus sessions later, for example, on auto scaling or things like that. So yeah, please keep an eye out on the various webinars that we can set up, that we regularly publish. I think we can wrap up the session for today, right? Difference, I see this question coming up again and again, difference between Docker and Kubernetes. So it's basically solving the same problem, both these tools, but the implementation is different. And if you have ever to choose between Kubernetes and Docker Swarm, always go with Kubernetes. Do not choose Docker Swarm. Docker Swarm is mostly done for academic purposes, for certifications and things like that. Some organizations still use Docker Swarm because it is easily available, but one day or the other, they move out to Kubernetes because it's a more sustainable solution. Okay. Thank you for your time. And I really appreciate your time with me. I hope this session was useful for you. And hopefully, I will see you around in subsequent sessions. Right. Thank you all. Have a good evening and take care. Bye.